All right, and our last case for SSA is going to be if we have two solutions. So this is the true ambiguous case. Two solutions is going to happen. I'm going to put this right here. If we have an angle, A, same kind of setup. So we have angle A, and this bottom side length I'm going to extend kind of, in this case, kind of far, because we don't know what that side length is going to be. And then we have B here. And of course we have a height. We can draw on that height if we wanted to. There's our height of the triangle. And then our side A. So the ambiguous case comes when you have a situation where the A value is bigger than the height, but it's also less than B. So if this A value is greater than the height, but it's also less than B, then we could draw one of two triangles. So if I said, if I had people drawing a triangle and I gave them the criteria and I said B has to be this long, let's say it's 10, and the angle is whatever, like 30 degrees, and I give you this, and I say that the side A is going to be like 9, for example. Someone in class could draw this and then draw out 9 units here, and then they would say, well, this is my triangle right here. I could draw it out like that and say, here is my triangle with all the requirements that you just gave me. Boom, right there. Someone else could take that same exact A value and whatever 9, and they simply could just draw it this way, and it would be the same length, and it would be the same angle would be intact, the same other side would be intact, but you could have two different possibilities. So you could have an A value that goes like this or like this. And so this is a case where, let's write this out, if A, I'm going to put this in the middle, if A is greater than H and A is less than B, then there's always going to be two solutions. So there's my two cases. And notice here that for these two triangles that we draw, okay, my angle B, one of the angles, so if this was my triangle, angle B, which is right here, is going to be acute, but for the second case, angle B right here is going to be obtuse. Okay, so there's a relationship. So if I put, if we write in that this is, this could be my angle B here, or this is my angle B here, I'm hoping you can see those two possible triangles. Those two possible triangles, the angle B, one's going to be acute and one's going to be obtuse. And more specifically, they are going to be supplements of one another. And we'll see that as we go through our example. All right, so here's the last example that we're going to do. And this is if we have two solutions. So go ahead and write this down. We have angle A is 35 degrees, side A is 17, side B is 20. And we can always kind of sketch out a triangle here. So angle A is 35 degrees. Actually, let me draw a little bit better here. So I know that this is 35. Side A is 17 and side B is 20. And so let's say we assume that it just looks like that for now, at least. That this is like that. and here's B, and then here's C. Now, immediately, since we see that A is less than B, we're either going to have one of two options. Since A is not greater than B, we're not going to have one solution. We're either going to have no solution, or we're going to have two solutions. If we want to know before we even start this problem what we're going to have, we're going to calculate the height. So if I think about my height right here, if I say what is the height, I would say the height is going to be, remember, it's going to be B times sine A, B sine A, which in this case is 20 times the sine of 35. So 20 sine 35 is 11.47. So 11.47. Well, remember our A value is 17, so our A value is greater than the height, which means we're definitely going to have two solutions here. Okay? If the A value was less than the height, we would know that we have no solution. So to summarize here, the A value, which is 17, it's greater than the height, so it is greater than the height of 11.47, but it is also less than the other side length, side B, which is 20. So because of that, we're going to have two solutions. Now, it's great if you can do that analysis beforehand and say, well, look, I know there's going to be two solutions here because I just checked it out. That's good. And even if, let's say, even if you didn't, you would still start off this problem and you'd still get one of the solutions, right? So we're going to use the law of sines here, okay? And I'll show you a couple tricks that you can use to check if there's two solutions at the end. If you didn't do this in the beginning, okay? Ideally, you would have that done right there. So let's go ahead and use the law of sines, and we're going to solve for, again, we have to solve for angle B. That's the only option that we have when we have SSA. We have to solve for angle B. So we start this off, and we say the sine of B divided by its opposite, which is 20, is equal to the sine of 35 over 17. And I'm just going to go ahead and cut right to the answer here. So B is going to equal, you're going to take an inverse sine, and you would have to multiply by 20 on the other side of the equation. Okay, so I'm going to do it all in my calculator here. I'm going to say the sine of 35, this will be times 20, divided by 17. So all on that side. And we would get 0.6747, etc. And actually, you know what, I'm going to write this. I'm actually going to write that in our notes. So 0.6747 about. So 0.6747, and I'm going to say this is the sine. The sine of B equals 0.6747. Now if I solve for B and I take an inverse, then I can approximate what the angle B is. So I go back here and I take an inverse sine of the answer, and it's 42.44. So 42.44 degrees. So now I have one of the three pieces of information that I need. I know that's 42.44. I could then solve for the other angle, right? Because everything adds up to 180. So I could figure that out by going 180 minus 42.44 minus the given angle, which is 35. And we could figure out that angle C is 102.56. So therefore, I could say angle C is 102.56 degrees. So there's my second piece of information. And of course, so let me take this picture here and update the information in it. I'm going to put this kind of off to the side here so I can see it better in the notes. So now we know all these angles. The only thing that we need to still find is side C, which is down there. So we would use the law of sines yet again and solve for side C, and then we would have our one solution. We'd have one triangle that we know is an answer. So if we're solving for side C, now I would use the law of sines again. In this case, I'm going to say C divided by its opposite angle, the sine of its opposite angle, 102.56, is equal to, and then you can pick any combination you want. In this case, I'm going to stick to the original, 17 divided by sine 35. So therefore, C is going to equal, I'm going to bring out the calculator, C is going to equal 17 divided by sine 35 on the right hand side, but then I would have to multiply on both sides by the sine of 102.56. So there's going to be my approximate side C, which is 28.93. So 28.93 is side C. And there is my first solution. 28.93. Okay, but as we know, there is a second solution to this. Okay, so the first one looks like this. The second solution is all going to stem from where we found angle B in the very first step here. So there's my first picture. My second solution, I'll put this kind of right here. The second solution would be something like, try to make this a little better. If this A side was not swung out here so that angle B was an acute angle, but what if it was drawn, remember, it could be drawn like this, or it could be drawn like over here. So what if we swung it to be like this? That is going to be our second solution. So therefore this bottom length is going to be shorter, or that side C is going to be shorter, and our second solution will be something like this. Okay, now, so this is our first solution over here. This is the first. Second solution. Now, the way that you get the second solution is all dependent on this angle B right here. The first solution, angle B, is 42 degrees, 42.44. The second solution is always going to be a supplement of that. Okay, so this angle right here is going to be 180 minus what we got for the first angle. Okay, so this is how you get your second solution. You kind of take what you have left from that first solution right here where we found angle B. The second angle B for the second solution is going to be 180 minus 42.44, which in this case, 180 minus 42.44, 137.56. So 137.56 is my second angle B. That describes that picture up there. Okay, so we have that. Now this is going to cause us to find two different values for angle C and side C. They're both going to be a lot smaller because look at the picture, right? So if I went with the second solution and now I found angle C, it's going to be, let's see, 180 minus that, 137.56, but also minus 35. Remember, angle A is still 35. And we only get 7.44. So now we say that angle C is only 7.44 degrees. Okay, which means when we find this side C, it's also going to be pretty small, right? So I'm going to fill in my picture here, 7.44. And now we do the same thing, and I'd find side C, which is going to be C divided by the sine now of only 7.44 equals 17 over sine 35. And we solve for side C again. So if I bring up the calculator one more time, I'll get 17 divided by sine 35. And then I have to multiply by sine 7.44. And I get about 3.84. So 3.84. And there is my second solution. So 3.84 goes here. And of course, these problems, there's two solutions, so it's going to take you longer to do, of course. So these can be kind of a pain to solve. But we have two solutions here. Now note, kind of as a recap, okay, once you understand that there's two solutions, then again, the way that we got the second solution is to understand that this angle right here, this angle B, we can get, if we take the supplement of this original angle B, so we get 42 degrees, we take the supplement of it, and we get 137. That starts off the second solution, and then we just go from there, right? So we have one solution that where angle B over here is acute, 42 degrees. The second solution, it looks like this, where angle B is obtuse. And it goes like that. You can see there's only, the angle B is only 7.44 degrees. Or sorry, angle B is 137.56 degrees. It's a lot larger. Okay, so there's my two solutions. Now one more thing, just to make one last connection, is you might say, you know, this is the point that I'm circling right here. Okay, if you look at sine of B equals 0.6747, that is the point in the problem where we can have a possible two answers. If you think about, I want to make one more connection to, yes, the unit circle. If you think back, and you don't have to use the unit circle here, but I just want you to think back to it. So here's the circle. You don't have to write this down. Okay. But that problem hinged upon this right here. We said the sine of B was equal to, what was it, 0.6747. 0.6747. So if I said on the unit circle, where is my y value? 0.6747. Now it's not one of those exact answers, but you could approximate 0.6747. That may be like right here, so that's like right here maybe, approximately. So this is the angle right here, about this, right? Which we got to be, remember, 42 degrees. Now, why does it make sense that there's two answers? Because on the unit circle, there's two places where the sine can be 0.6747. The other angle is over here in quadrant 2, which is where we got the 137 degree angle. 137 degrees, but we also had this 44 degrees. There's two answers here, right? So make this connection. That's why in this problem, this is the point where we can break off and make a second solution, is because that sine of b equals 0.6747. There can be two answers to that problem right there. Okay, so I know there's a lot to take in with two solutions. When you do homework problems, you're not going to have many of the two solution types. You're going to have some types that are just no solution, that are really quick and easy, and you might have one, maybe two problems where you actually have two solution types of answers. Okay, I hope that gives you a good introduction. You can begin working on that homework.